Hello friends, in this video I am going to discuss about basics of differential protection of transformers. Now for understanding the implementation of differential protection of transformers, let us consider a network in which there lies a transformer. Now the primary side of the transformer will be obtained from a bus bar and the secondary side would come and terminate at another bus bar. Now from this bus bar we can have many other feeders. Like suppose this is feeder number 1, we can have another feeder which is feeder number 2, and we can have one more feeder which is feeder number 3, and all the three feeders are going and terminating at different places, and we have loads connected to this. And like we have a load at feeder number 1 end, load at the end of feeder number 2, and load at the end of feeder number 3. Now since this transformer is not going to supply any power to these loads, so for supplying power to these loads, what we have to do, we have to run a generator. So there comes a generator. Now this generator, after generating power, it is going to supply to the bus through a GT. Means suppose this is a 220 kV bus and it is a step down transformer, and this is considered to be 33 kV. So this generator, after generating power and stepping up the voltage to 220 kV through this GT, that is a generator transformer, it is giving power to this bus, and through this transformer it is being fed to the loads. Now in general conditions we don't have a single transformer. For the purpose of reliability, what we do, we add one more transformer for the parallel operation. Like we have one more transformer, and let me number this as 1 and number this as 2. Now for the protection of each and every electrical equipment what I have drawn here, we have to introduce circuit breakers. So for the protection of feeder 1 we have to introduce a circuit breaker over here, for 2 we have to introduce a circuit breaker over here, for feeder 2 we have to introduce a circuit breaker over here, for feeder 3 we have to introduce a circuit breaker over here, for the protection of generator we have to introduce a circuit breaker over here, for GT we have to introduce a circuit breaker over here, and for the protection of transformers, one circuit breaker on 220 kV side and the other on 33 kV side. Now for transformer 2 also similar thing happens. Okay, now for implementing the differential protection of transformer 1 and 2, we have to introduce two CTs, one CT on the 220 kV side and the other CT on 33 kV side. Similarly for transformer 2, one on 220 kV side and the other on 33 kV side. Now the general differential protection is as such: we just connect these two terminals and we connect these two terminals, and we introduce a relay coil in between these two wires. Similarly for transformer 2, a relay coil is introduced between these two terminals, and the name given to this relay coil is 87. Now 87 is the NEMA schematic for the differential protection. Now the purpose of this relay is that it is going to give a tripping signal to this circuit breaker and this circuit breaker whenever there is a fault in the differential zone. The differential zone means the zone covered by the CTs, that is the CT on 220 kV side and CT on 33 kV side. So whenever there is a fault in between these two CTs, like suppose if there is a fault at this point or there is a fault at this point, it is considered to be a fault in differential zone, and during that condition this relay should operate and it should give a tripping signal to this circuit breaker and this circuit breaker, and the transformer should get isolated in order to clear the fault, and the power supply to the loads should continue through this transformer number 1. Now this relay should not give any tripping signal to this breaker and this breaker whenever there is a through fault. Through fault means fault outside of the zone, means if there is a fault at this point, then this breaker and this breaker should not trip, means this relay should not sense any current and should not give any tripping signal to these two breakers. Now let us see how these things are happening. Let us suppose there is a fault in feeder 1. So this fault will be fed through the generating station, so the current through the generator will flow in this direction and it will come up to this point, and through this transformer also it will take up this path and it will flow in this direction. Now during that condition, let us see how the 87 relay, that is the differential relay, is behaving. In order to balance this current, there should be a flow of current in the secondary in this direction, and similarly in order to balance the flow of current in this direction, there should be a flow of current in the CT secondary in this direction. So it is going to take up this path and this current is going to take up this path. Now since we can see that both these currents are in opposite directions, so the current flowing through this relay will be I is equal to 0, and this relay is stable, so this circuit breaker and this circuit breaker is not going to get any tripping signal, and they are going to be in service. Similarly, for transformer 2, the current should flow in this direction, and for this side the current should flow in this direction. So we can see that here also the currents are opposing in nature, and the current I will be equal to 0, and it is not going to give any tripping signal to these two circuit breakers. So in order to clear the fault, our tripping signal is given to this circuit breaker, means the circuit breaker of feeder 1 trips and the circuit breakers of transformer 1 and 2 remain in service, and power to feeder 2 and feeder 3 is extended through transformer 1 and 2, means there is no disruption in supply to feeder 2 and feeder 3. Now let us consider a situation in which there is a fault in the differential zone of one of the transformers, and how the differential relay of both the transformers are going to behave during that condition. Let us suppose there is a fault at this point. So how the fault current will be fed is, from this 220 kV bus the current will flow in this direction, and similarly this transformer is also connected to the circuit, so current will flow in this direction through this bus. It will take this path and it will get added up at this point, and fault current will keep on flowing through the circuit. Now about transformer 2, the current should flow in this direction for the primary side CT secondary, and for the secondary side CT secondary, in order to balance this current, the current direction will be in this way. So at this node we can see that both the currents are coming and they will get added up, and there will be a flow of current in the differential relay, and hence this relay is going to operate, and it will send a tripping signal to this circuit breaker and this circuit breaker, and these two are going to get opened, and now the faulty section will be isolated. Now what about the healthy transformer? The differential relay would see the fault as there will be fault current flow in this direction, and there will be a fault current flow in this direction. So since we can see that both the currents are opposing in nature, so the current flowing through this coil will be I is equal to 0, and hence this transformer will remain in service even if there is a fault in transformer 2. And since the fault has been cleared by opening of these two circuit breakers, this circuit breaker and this circuit breaker, now the faulty section has been isolated, and power through transformer 1 will be extended to the feeders, that is the feeder 1, 2 and 3 of the transformer. So this was about the design of differential circuit of a transformer. Now let us just consider a situation in which there is a mistake in designing the differential circuit of the transformer. So we can see that the differential protection circuit of transformer 2 has been changed, and it is different from that of transformer 1. Now let us see how this circuit would behave when there is a fault in the system. Let us suppose that transformer 1 is seeing a fault at this point. So since there is a fault at this point, there will be a flow of current in this fashion, and from this transformer 2 there will be a flow of current in this direction. So it would take up this path. Now the current in transformer 1 would flow in this direction, and similarly in order to balance this current, it would flow in this direction, and at this node both these currents are getting added up and it will flow in this direction, and hence the 87 will operate, means this circuit breaker and this circuit breaker should open since there is a fault in the differential circuit of the transformer. Now about the behavior of transformer 2, we can see that the current would flow in this direction, and for this the current would flow in this direction. It would take up this path, and at this point it is going to, the 87 relay is going to see a flow of current in this direction, and hence it is also going to see this as a fault, and this 87 relay will send a tripping signal to this circuit breaker and this circuit breaker, and this transformer will also come out of service when there is a fault in transformer 1. So hence this leads to total power failure at 33 kV level, and there will be a total interruption of supply to feeder 1, feeder 2 and feeder 3. Now for the same circuitry, let us assume that there is a fault in feeder 1. So the fault current would flow in this direction, and it would flow through transformer 2 in this direction. So in order to balance this, current should flow in this direction. In order to balance this, current should flow in this direction. And since both these two currents are opposite in nature, so I will be 0, that is the current flowing through a differential relay will be 0. For this it is like the current should flow in this direction and it should flow in this direction. So at this point both of them are getting added and there will be a flow of current through differential relay, and this transformer is going to trip. This transformer will trip means it is going to, this relay is going to send a signal to this circuit breaker and this circuit breaker, and both of them are going to operate even when there is no fault within the differential zone of the transformer. Means due to mistake in the circuitry, the transformer is tripping even for through faults. Hence, the connection of CTs should be considered carefully while designing the differential circuit of the transformer. This was all about the basics of differential protection of a transformer.